Hey chemistry! Yesterday in our class meeting, we started to talk a little bit about why different columns on the periodic table share trends, and we talked about the number of electrons they have and started drawing Bohr models. I wanted to take a step back today and talk a little bit about what makes the nucleus of atoms stable or unstable. And the way you're going to do that is using a simulation that probably looks familiar. So in the resources section of the class, I've included this page. As usual, you don't have to print it. If you want to, you're welcome to write your answers in your notebook. Step 1 says go to PhET Build an Atom and choose Atom. So this is PhET Build an Atom. It should look familiar. And when you get here, hit the play symbol and then click on Atom. When you get to Atom, there's 3 things that you want to change for our activity today. You want to open net charge, mass number, and you also want to click on stable or unstable. The first part of the assignment asks you to play with the simulation and then answer the questions. You should be able to answer most of them based on what we've already covered in class. The question we're trying to answer in part 2 is how many protons, neutrons, and electrons does it take to make a stable atom? And you're going to determine that using the simulation. The element is given below. Determine the number of protons, neutrons, and electrons to make it stable. And it gives you the element symbol in the left column. So the first one is hydrogen. Let's do that one together. So I'm going to build a hydrogen. And we're trying to figure out how many neutrons when it's stable. So with 1 neutron, hydrogen is stable. Let's see what happens when we add a second. Nope, so 2 neutrons make hydrogen unstable. So in our chart, protons is 1, neutrons is 1, electrons is 1, mass is 2, symbol is H, and net charge is 0. You're going to continue to do the same until you've filled in the chart, and then there are 3 questions for you to answer at the end. To get a stable atom, which particles matter most, which particle doesn't matter, describe in your own words when an element is likely to be stable and when it isn't. And third, what happens when an atom is unstable? I've included an article that can help you answer that last question. If you'd like some help or would just like to work it with me, be sure to stop by office hours today. I hope to see you there. Bye, chemistry!